Good morning. Today we are going to discuss about fourth chapter, that is quadratic equations. So that is quadratic equations. Now let us try to understand what is quadratic equations. For that, we need to understand and we need to recall what do you mean by a quadratic polynomial. So, quadratic polynomial is a polynomial whose degree is equal to 2. And what is the standard form of a quadratic polynomial? P of x is equal to ax square plus bx plus c, where a is not supposed to be 0 as well as b comma c both are real numbers. Now ax square plus bx plus c is said to be a quadratic polynomial in terms of x, and we learnt about quadratic polynomials in second chapter. And now what is the difference between a quadratic polynomial as well as a quadratic polynomial equation? Let us try to understand with one example. Okay. So, for example, I have taken x square plus 5x plus 6 is a second degree polynomial, and taking one linear polynomial like x plus 5 is a linear polynomial. This is a second degree polynomial and this is a linear polynomial. In these two polynomials, let us consider x plus 5. For what value of the variable x, x plus 5 will become 0. That value of the variable is said to be 0 of this linear polynomial. So, for x is equal to negative 5, x plus 5 will become 0. So, that this negative 5 is said to be 0 of the polynomial. So, there is only one value of the variable which makes the polynomial 0, that only one value of the variable for this particular linear polynomial is said to be 0 of the polynomial. For example, if you put x is equal to 1, then x plus 5 will become 1 plus 5 is equal to 6. If you put x is equal to 2, then 2 plus 5 is equal to 7. So that this polynomial expression will give the values according to the values of the variable. There is no fixed value for this x plus 5 as it is an expression. Similarly, x square plus 5x plus 6. This is being a second degree polynomial. If you want to find out zeros of the polynomial, then you will have to factorize this by splitting middle term method or any of our algebraic methods. So now let us try to understand how to split this middle term by factorization method. Since the product of x and 6 is 6x square, and moreover this is positive, so that positive 6x square. And now if you split this 6 into two terms, such that the sum of the two factors is going to be positive 5. Therefore, the factors of 6 are 2x as well as 3x. And now this is positive, so that both the terms are going to be positive. Right? Then you can split this 5x as plus 2x and plus 3x. Therefore, x square plus, instead of 5x we can write plus 2x plus of positive. And moreover 3x plus 6, from 3x plus 6 you can take at the maximum 3 common, remaining x plus 2. So finally the common factor in the entire expression is x plus 2, so that taking x plus 2 common into the other term is here x and the other term is here plus 3. So these are the factors of this polynomial. Now we can understand one thing, that for what value of the variable x, this entire polynomial will become 0. If you once observe, this is the product of two terms. When the product of two terms is going to be 0, either first term equal to 0 or second term equal to 0, of course both the terms are equal to 0. So if you observe this first term x plus 2 is going to be 0 when x is equal to minus 2, as well as x plus 3 is equal to 0 when x is going to be minus 3. So for x is equal to minus 2 as well as for x equal to minus 3, this entire polynomial will become 0. Therefore, the zeros of this second degree polynomial are minus 2 and minus 3. Here x plus 5, there is a single expression, like it's a linear expression, and 0 of this polynomial, we are not talking about zeros of the polynomial, talking about only 0 of the polynomial, because the degree of this polynomial is 1, since it is a linear expression. That's why it has maximum of 1 0. But being it is a second degree polynomial, it has maximum of 2 zeros. Why am I using the word maximum of 2 zeros? Because if you observe one more expression, like I am taking one more second degree expression, that second degree expression is going to be x square minus 4x plus 4. This is one second degree expression. If you factorize the second degree expression by splitting middle term method, x square minus 2x plus 4, then from the first two terms you can take one x common, remaining x minus 2. Immediately you have negative sign common, and then from 2x and 4 you can 2 common and remaining x minus 2. So totally you have x minus 2 is the common factor, and remaining term here it is x and here it is minus 2. What does it mean? X minus 2 into x minus 2 means x minus 2 is repeated factor. So you can write it as x minus 2 whole square. Now this x minus 2 whole square will become 0 only when the value of x is equal to 2. So it means this second degree polynomial is 0 only for one value of x, that one value of x is 2 only. But in the previous example, like you have taken x square plus 5x plus 6. So this is a second degree polynomial, will become 0 for two values of x. But here it is 0 only for one value of x. So that is why we can say that the maximum number of zeros of the second degree polynomial is 2. We should not say that exactly 2 is the number of zeros of the polynomial of degree 2. So we can generalize one thing here with the help of this conversion for the first degree polynomial as well as second degree polynomial. Suppose you have a polynomial of degree n. Polynomial of degree n. Polynomial of degree n means p of x is a polynomial of degree n. For example, a0 x to the power of n plus a1 x to the power of n minus 1 plus so on. So this is nth degree polynomial. What is the maximum number of zeros of this nth degree polynomial is at most n. We should say that at most n. We should not say that exactly n. We already discussed about that. Why is it not exactly n? Why is it at most n? So this is about a single polynomial which is a linear polynomial as well as a quadratic polynomial. Now I am taking one quadratic polynomial equation. That quadratic polynomial equation is, for example, x square minus 3x plus 2 is equal to 0. This is a quadratic polynomial equation. More precisely, this is a quadratic equation. And taking a quadratic expression, that is x square minus 3x plus 2. So this is a quadratic expression. What is the difference between a quadratic polynomial equation and quadratic expression? See here, which is equal to 0. Something is equal to 0. Something is equal to 0 means there is an unknown. That unknown over here is x. So this unknown can be found out by factorization method or by any algebraic method. But whereas x square minus 3x plus 2 is not equal to anything. Since it is not equal to anything, there is no particular value of x which satisfies, because there is no equal to something. Since it is equal to 0 means this entire left hand side term is going to be 0 for some value of x or two values of x or three values of x. It does not matter. That depends on the degree. Since it is a second degree polynomial, just now we discussed about how to find zeros of the polynomial. So since it is being a second degree polynomial equation, it has maximum of 2 zeros. But when you substitute that 0, for example, x is equal to 1 or x is equal to 2, when you substitute over here, then this quadratic equation will be satisfied by that value of x. So for what value of the variable the given quadratic polynomial equation is going to get satisfied, those values of the variables are said to be solutions or roots of the given equation. Solutions are roots of the given equation. So now whatever the zeros of this polynomial are said to be the roots or solutions of this quadratic polynomial equation. So that is only the difference between a polynomial as well as a polynomial equation. Got it? So now we are going to describe more about this quadratic polynomial equations or quadratic equations, and in different cases whether it is really possible to figure out the roots of any quadratic polynomial by splitting middle term method or not. Okay. So let me take some examples to identify the zeros of the polynomial, if it is possible to find out by using factorization method or not. For example, there is a polynomial like x square plus 5x plus 4 is equal to 0. This is one quadratic equation. And another quadratic equation is x square plus x plus 1 is equal to 0. This is one more quadratic equation. Now let us try to understand, is it really possible to figure out the roots of the given quadratic equation by our traditional method, that is factorization method or splitting middle term method or not. Okay. If you once observe x square into 4 is equal to 4x square, that is also plus 4x square. Will you be able to factorize this 4 into two factors such that their sum is going to be 5? Yes, obviously we can write 4 as 1 4s are 4, and moreover when you add 1 and 4 you will get 5, so that it can easily be factorized by splitting of middle term method. Whereas x square plus x plus 1 is equal to 0, this is one of the quadratic equation. Now when you multiply x square and 1, that is going to be 1x square or x square, and now when you factorize this 1 you should get the sum of the factors is also equal to 1. The only factors for 1 are 1 and 1, but when you add 1 and 1 you will get 2, but you cannot get 1. So it means that it is not possible to factorize this kind of quadratic equations by splitting middle term method or factorization method. So is there any other method to figure out the factors, otherwise to find out the roots of a given quadratic equation? Let us try to understand this. Now everybody has to understand how this scenario is going on, and moreover what are the logical sequence of steps being involved in proving this one particular explicit formula to find out the roots of any quadratic equation, right? So let us consider one standard form of quadratic equation. What is the standard form of quadratic equation? Ax square plus bx plus c is equal to 0. Of course there are conditions like a is not equal to 0, b and c, all these three numbers are real numbers. So by default ax square plus bx plus c equal to 0 is the standard form of quadratic equation, right? Now I am going to find out the roots of this quadratic equation by using our algebraic identities. So we have some algebraic identities which has three terms in its expansion. So which algebraic expression has three terms, which identity has three terms in its expansion? Let us try to understand what is the formula for a plus b whole square. The formula for a plus b whole square is going to be a square plus 2ab plus b square, right? This is the formula for a plus b whole square. Like you have the formula for a minus b whole square, that is a square minus 2ab plus b square, but in our formula we have positive sign for the middle term. That is why we will try to understand a square plus 2ab plus b square in order to convert this ax square plus bx plus c equal to 0 as a square number. So how is that possible? Let us figure it out. See, the first term is a square. So it is understood one thing, that you will have to convert this first number ax square as a square number. So how do you write ax square as something whole square? So you can write ax square as x square is being a square number, but a is not a square number, so that you can write it as square root a x whole square. so that you can write ax square as square root a x whole square. But involving square roots as well as fractions in the given expression makes your problem so complicated. So that is why, just to avoid these kind of square roots as well as fractions, let us think broadly to avoid all these things, and we will try to get this number as a square number just by multiplying a fixed number. See, it is possible to convert this ax square, to convert it into a square number just by multiplying, because x square is already a square number, but a is not a square number. If you simply multiply by a, it will become square number, right? Because a into a is equal to a square. So a square into x square is a square number. That's much easier than writing that a as square root a whole square. But you will have to think about the second term also. The second term is going to be 2ab. So 2 must be there. But if you multiply by a, it is going to be a into bx. But there is no 2. So that we need 2 also. So it is understand one thing, that you need to multiply the first term definitely by a, as well as by one more number whose multiple is 2, and it should be a square number. So I think you got that number is going to be 4. So that you will have to multiply the entire equation by 4a. Okay, so multiplying the entire equation by 4a, then it is going to be 4a into ax square plus bx plus c is equal to 4a into 0. Got it? Now multiply every single term by 4a, then you get 4a into a is equal to 4a square, and x square is also there, plus 4a into bx is 4abx plus 4a into c is equal to 4ac is equal to 4a into 0 is going to be 0. Right? Now let us start converting this into the form of a square plus 2ab plus b square. Writing this 4a square x square as a complete square number, 4 is 2 square, a square is a whole square, x square is x whole square, so that you can write 4a square x square as 2ax whole square, and then second term is 2ab, so our a is decided, so a is 2ax plus 2ab plus 2 into a was already decided as 2ax, so 2 into 2ax into how much is equal to 4abx. Once you see 2 into 2 is equal to 4 into x is equal to 4ax. 4ax into how much is equal to 4abx? We left with b only. So that our b is b only. Right? But a is 2ax, but b is b. So plus, what is the other term in the expansion? That is b square. So b square. But once you observe in this expression, b is not there, b square is not there in any term. But we want that b square in order to make this one as a square number. So that for balancing, you will have to subtract it. Right? Did you understand? We are adding b square as well as subtracting b square, because we want b square to make it as a square number. Since we are adding newly, to balance this equation, you will have to subtract it. And we left with one more term, that one more term is 4ac. So that plus 4ac equals to 0. Hope you understand this? Right. Now if you once observe from here to here is in the form of a square plus 2ab plus b square. So a square plus 2ab plus b square is going to be a plus b whole square, and then the other terms are, this is minus b square, and plus 4ac is plus 4ac is equal to 0. Right? Since we want the value of x, leave this 2ax plus b whole square on the left hand side and transpose the other two terms towards right hand side. Then it is going to be 2ax plus b whole square is equal to minus b square will become plus b square, and plus 4ac will become minus 4ac. Right? Since we want x, so that x is located here, but this term has a square. So that when you remove the square, what has to be done? So here we generally say, for example, x square is equal to 4. When you see that x square is equal to 4, then if it is the point for finding the value of x, then we simply say that x is equal to root over 4. But you will have to think logically here. What do you mean by this x square is equal to 4? X square is equal to 4 means x is an unknown. Some number whole square is equal to 4. So you will have to think in such a way that square of which number is 4. So square of which number is 4? Everybody knows that square of 2 is equal to 4, right? But you will have to think more. Square of one more number is also equal to 4. What is that number? Yes, that is square of negative 2 is also equal to 4. So what did you understand here? Square of 2 is 4 as well as square of minus 2 is also equal to 4. Therefore, when you are finding for x here, when x square is equal to 4, you should write x is equal to plus 4 or minus 4. See here, plus or minus. That's why you should write plus or minus and then you put square root 4. Because it can be positive 2 or it can be negative 2. So that's why you can say that it would be plus or minus 2. Hope you understand what I am trying to tell you, because this is 2ax plus b whole square is equal to b square minus 4ac. You are going to find out the value of x. For that you will have to remove the square. So when you remove the square, you will have to put plus or minus square root. Please be very careful. Okay, we cannot take only the positive square root. It can be the negative square root also. So that you can take the value here, that 2ax plus b is going to be plus or minus square root b square minus 4ac. Correct? But still you want the value of x, right? See, this x is grouping with some other terms. So try to make that x alone, means try to make that x as a subject. Okay, for that, first of all, this b is alone, transpose that b towards right hand side. Since it is positive b, it will be negative b towards right hand side. So that it is going to be 2ax is equal to plus b will become minus b. I am writing minus b, but already we have plus or minus square root b square minus 4ac. But still we have 2a here. So that this 2a is multiplying here, when you transpose towards right hand side, it will divide. So therefore, the value of x is going to be minus b plus or minus square root b square minus 4ac whole divided by 2a. This is what is called quadratic formula to find the roots of any quadratic equation. Right? So what is that formula to find quadratic to find the roots of any quadratic equation? So that formula is going to be x is equal to minus b plus or minus square root b square minus 4ac whole divided by 2a. Okay, this formula is known as quadratic formula. What is the use of this quadratic formula? To figure out the roots of any quadratic equation. I have written one quadratic equation there which cannot be factorized by using splitting middle term method, but that can also be factorized, that can also be found the roots by using our quadratic formula. I will write this quadratic formula briefly. So I hope you understand how to derive this quadratic formula, right? For ax square plus bx plus c is equal to 0. Once again make a note of it, that x is equal to minus b plus or minus square root b square minus 4ac whole divided by 2a. Correct? So I will write that once again here for the roots of a quadratic equation, ax square plus bx plus c is equal to 0. So that is, the roots of the quadratic equation are the roots of a quadratic equation. What is that quadratic equation? Ax square plus bx plus c is equal to 0, or x is equal to minus b plus or minus square root b square minus 4ac whole divided by 2a. See here, it is having minus b plus or minus root over b square minus 4ac by 2a. Means you can use plus for getting one root as well as you can use minus for getting the other root. So let me explain by taking one of the examples. Okay. So for example, the given question is, find the roots of x square minus 11x plus 10 is equal to 0. Of course, this quadratic equation can be solved by using splitting middle term method also. But since we derived the formula, let us see how far this formula work out, okay, to find out the roots. And before you use the formula, you will have to compare the given equation with the standard form of quadratic equation just to identify the values of a, b, c. Okay, so that I am writing the quadratic equation in the standard form, which is equal to ax square plus bx plus c. Now identify the values of a, b, c. What is the value of a here? A is the coefficient of x square. Then what is the coefficient of x square here? If nothing is there, then it means 1 should be there, because 1 into x square is equal to x square. So that 1 is the value of a. Similarly, what is the value of b here? That is plus b, which is equal to minus 11. It means the value of b is equal to negative 11. And the value of c is going to be 10. So the value of c is equal to 10. After identifying the values of a, b, c, substitute back in the formula. That is x is equal to, once again you write the formula, that is minus b plus or minus square root b square minus 4ac whole divided by 2a. Right? Shall we substitute the values? Yes, which is equal to, first negative is there, so negative. The value of b is going to be negative 11, so that negative 11 plus or minus square root b square. Since b is equal to negative 11, b square means negative 11 whole square. Should not avoid that minus. Okay, so minus 11 whole square minus 4 times a. A is going to be 1, so 4 into 1 into c. C is going to be 10. Okay, so whole divided by 2 times a, that is 2 times a is equal to how much? A is equal to again 1. Correct? Which is equal to negative of negative 11 is equal to 11 plus or minus square root negative 11 whole square. Negative square is equal to positive and 11 square is equal to 121. And then minus 4 into 1 into 10. 4 into 1 equal to 4 into 10 is equal to 40. So that minus 40 whole divided by 2 into 1 is equal to 2. Now understand this is, which is equal to 11 plus or minus square root. Once you observe 121 minus 40. What is 121 minus 40? First of all, 120 minus 40 is of course 80 and 1 is extra. So that it is 81. Whole divided by 2 into 1 is equal to 2. You all know that what is the square root of 81, which is equal to 9. So that you can write it as 11 plus or minus 9 divided by 2. This is the value of x. But there are two values of x. By splitting this plus or minus, for getting one root you use plus, for getting other root you use minus. So that you can write it as 11 plus 9 divided by 2 is one root, and second one is 11 minus 9 divided by 2. 11 plus 9 is equal to 20. 20 divided by 2 is equal to 10. So 10 is one of the roots, and 11 minus 9 is equal to 2 by 2 is equal to 1 is the other root. So therefore the roots of this quadratic equation, are 10 comma 1. See how easily we can find the roots of this quadratic equation just by using this quadratic formula. And in the other case, we have taken one more quadratic equation which cannot be factorized by using splitting middle term method. So let us think about that quadratic equation to figure out the roots. Okay, so for example, I am taking that kind of quadratic equation. So that quadratic equation is like x square plus x plus 4 is equal to 0. This is one quadratic equation. In fact, this quadratic equation cannot be factorized by using splitting middle term method. Then I am comparing this quadratic equation with the standard form, that is ax square plus bx plus c. So better try to figure out the values of a, b, c, just to avoid all such confusions. The value of a is equal to, this is ax square, this is only x square. Only x square means 1x square. So that the value of a is equal to 1, and b b is equal to coefficient of x. Here what is the coefficient of x? That is equal to 1. So that b is equal to 1 and the value of c is going to be, what is c here? C is equal to 4. So c is equal to 4. Okay. After identifying the values of a, b, c, let us go to quadratic formula and then substitute back in that. Okay. So what is that quadratic formula? X is equal to, already we have written here, x is equal to minus b minus the value of b is equal to 1 plus or minus square root b square, b is equal to 1. So that 1 square minus 4 into a into c, again a is equal to 1 as well as c is equal to 4 whole divided by 2 times a is equal to 1 again, correct, which is equal to minus 1 plus or minus square root 1 square is equal to 1 minus 4 into 1 into 4 is equal to 16 whole divided by 2 into 1 is equal to 2. Now see here, which is equal to minus 1 plus or minus square root 1 minus 16 is going to be negative 15 whole divided by 2 into 1 is equal to 2. What is this root over negative 15? We heard about negative root over 15, but we do not know about root over negative 15, because if negative sign is there inside the square root, then that number cannot be considered as a real number. So that this number is not available in real plane, right? Then where this number is available? This number is available in complex plane. So this number belong to the complex number system. And what exactly the meaning of this number? Let us try to understand. See, this is root over negative 15. You can write this root over negative 15 as root over negative 1 into 15, right? You can split that square root for both the two terms, for negative 1 as well as for 15, and you can write it as root over negative 1 and root over 15. And you know what is the value of root over 15? It is purely an irrational number. But coming to this root over negative 1, it is not a real number. And the value of root over negative 1 is named as I. That is what called imaginary number. Why is it called imaginary number? Because it is not available in real world. Okay. So it is available only in imaginary world. That's why it is called I. So the fixed value of I is equal to square root of negative 1. So that is the fixed number, you can remember that. It will not be changed. Okay. So the value of I, wherever you go, the value of I is equal to root over negative 1. Okay. That I is called imaginary number, right. So root over negative 1 is equal to I and root 15 is root 15 only. So finally, what is the value of this root over negative 15? Root over negative 15 is equal to I into root over 15, right. So if you write those values in the place of root over negative 15, then the value of this quadratic formula and the quadratic roots will become negative 1 plus or minus I into root over 15 divided by 2, right. Now we can split it into two roots. Those two roots are, therefore x is equal to, first one is minus 1 plus I into root over 15 divided by 2, comma second one is negative 1 minus I into root over 15 divided by 2. So these two are the roots of the given quadratic equation. So like that we can figure out the roots of any quadratic equation by using this quadratic formula, right. And then let us move on to what is the relationship between roots and coefficients of a quadratic equation. So roots and coefficients of quadratic